Okay, so hello everyone. Our today's topic is advanced data visualization techniques. We learn about data visualization like in our previous lecture. Now we will um, learn advanced data visualization techniques. And as you all know, data has become a center part of our lives, whether in business, science, or even our personal decisions. Data plays a pivotal role. So, but so more than having access to large data sets, it is how we present and interpret the data that makes a difference. So why this data visualization matters? As we all already discussed in our previous lecture, in its raw form, data can be difficult to interpret. We often deal with thousands, if not millions, of data points, and without the right tools, identifying patterns, trends, or even anomalies can be daunting. This is where data visualization comes into play. So, like I said before, it allows us to communicate complex information in a much simpler way. It provides clarity and insights uh, alone, so which numbers alone cannot offer. So we will just move beyond the basics and explore advanced techniques that help us unlock even more potential from our data. So we will look into a variety of topics. So let's get started. So before we dive into the advanced techniques, let's first establish a common understanding of what data visualization is and why it's crucial in today's data-driven world. So it is the graphical representation of information and data by using visual elements like charts, graphs, and maps. Data visualization tools provide an accessible way to see and understand trends, outliers, and patterns in data. It transforms the raw data into a visual context, which makes complex information more digestible for humans. So, um, so why advanced techniques? Mm, well, before going to the advanced techniques, so visualization is not just about making things look aesthetically pleasing. It plays a key role in data analysis and decision making. When presented effectively, it provides clarity, helping decision makers focus on what's important. For example, it allows executives to quickly identify which areas need attention or improvement, spot emerging trends, and make data informed decisions. Now we'll see why advanced techniques. Why we'll use advanced techniques. So as our data, as the data, um, so as the complexity of our data continues to grow, so does the need for more sophisticated methods of visualizing it. Simple bar charts and pie charts are no longer sufficient when we are dealing with multi-dimensional data sets or real-time data. So advanced techniques allow us to represent more complex relationships within data. It provides interactive elements that allow users to explore the data more deeply. It draw out insights that may be hidden in the sheer volume or complexity of the data. So, um, so we will explore various advanced tools and methods that go beyond the basics, giving you the ability to effectively communicate data insights in this complex environment. So now that we have discussed the importance of data visualization, let's move on to the different types of visualization available to us. So broadly, we can categorize them into two main types: traditional and advanced. So in traditional one, we have bar charts, which is one of the most basic visualization used to compare different categories of data. We learned those things in our previous lecture. Then line graphs, often used to display trends over time. Line graphs are useful when you want to show how one or more variables change in response to another. Then pie charts, which are used to represent parts of a whole, showing how a data set is divided into proportional segments. Then scatter plots, when you need to show the relationships or correlation between two variables, it can be extremely useful. So these traditional visualization methods are highly effective for straightforward data sets, but as data complexity grows, we need to employ more advanced techniques to gain deeper insights. When traditional visualization falls short in communicating intricate or multidimensional data, we turn to more advanced types. So first, if we see heat maps, these visualizations represent data in matrix form, where individual values are represented as colors. Heat maps are excellent for showing the density or frequency of data points. Tree maps. Tree maps display hierarchical data as a set of nested rectangles. The size and color of each rectangle can be used to convey two dimensions of the data. Radar charts, also known as spider charts, these are used to plot one or more groups of values across multiple axes. They are useful when comparing multiple variables across categories. So I'll show you those graphs and charts, images. Network graphs, these show relationships between data points, making them particularly useful for visualizing social networks or communication flows. Then lastly, we have Sankey diagrams. Sankey diagrams illustrate the flow of resources or data between different states or nodes. These are often used in process flows, energy management, or any data that involves movement between categories. So by using these advanced techniques, we can represent complex data relationship and extract valuable insights that are otherwise difficult to perceive through traditional methods. So here are the images of heat map from first to last. First one is heat map, then tree map, radar chart, then network graph, then the last one is Sankey diagram. So now that we have explored different types of visualization, it's essential to understand how to choose the right one for your data. So not all visualizations are created equal. What works for one dataset or story may not work for another. So the decision comes down to a few key factors: the type of data you have and the story you want to tell. So first of all, it depends on the type of your data. So if it's a categorical data, categorical data refers to variables that represent categories, for example product types, regions, or customer segments. The best visualization for categorical data are bar charts, pie charts, and heat maps, as they allow us to compare quantities across different categories. Then if we have if the data is numerical data, so the numerical data is these are such as revenue figures, visualizations like temperatures or population growths. Visualizations like line graphs or scatter plots help to show changes over time or relationships between variables. So these two So if we have categorical or numerical data type, we can use basic tools. Then the third one, if we have like time series data, this refers to data points collected or recorded at specific time intervals. So time series data is best visualized through line graphs or area charts to depict trends, peaks, and throws um, um, over a period of time. So basically, for three of these data types, we are using the basic tools, basic techniques. Now for relational data, if you're working with data that depicts relationships or interactions such as social networks, workflows, or process, then we can use an advanced technique, which is network graphs or Sankey diagrams. That will be a good option. So depending on your data type, then we will think which data or which tool we are going to use, basic tool or advanced tool. So questions to ask, like to make the right choice, there are two key questions you should ask yourself. So first one is, what story are you trying to tell? So every data visualization tells a story. Before selecting the type of visualization, ask yourself what insights you want the audience to gain. Are you trying to highlight trends over time, showcase a comparison between categories, reveal the underlying patterns or relationships in the data? So what story you want to tell? Depending on this answer, you can make the right choice. Now, who is your audience? Your audience plays a critical role in determining the complexity and depth of your visualization. For example, a technical team might appreciate complex network graphs or scatter plots with regression lines. On the other hand, executives might prefer simplified bar charts or dashboards that summarize key metrics without diving into the intricate details. So if you have those answers for those questions correctly, you can choose the right tool for you, because choosing the right tool is very important. It just like by selecting the visualization that best fits the context, you ensure that your data tells a clear, effective, and compelling story. Advanced techniques, interactive visualizations. Now, in today's digital age, data is not just something we look at, it's something we interact with. One of the most powerful tools in modern data visualization is the use of interactive dashboards. These allow users to engage directly with the data, making it possible to explore real-time trends and discover insights tailored to their specific needs. Now, let's start by looking at two popular platforms for building interactive dashboard. One is Tableau and Power BI. These tools have revolutionized the way we visualize and interact with data by enabling real-time exploration, something that static graphs and charts simply cannot achieve. So, Tableau is known for its powerful data analytics capabilities and beautiful customizable visualization. It allows users to quickly build interactive dashboards with minimal coding experience. It's highly responsive, making it ideal for real-time data updates. And then, if we talk about Power BI, Microsoft's Power BI focuses on making data accessible to everyone. It's integrated with Microsoft tools and enable users to create simple yet highly effective interactive reports and dashboards. Power BI also stands out for its ability to link various datasets effortlessly and create real-time insights. Now, what are the advantages of interactive dashboards? As I said, Users can manipulate the data in real time. This means they can filter the data, drill down into specifics, and uncover insights instantly rather than relying on pre generated reports. Then, so interactive visualizations are much more engaging than a static diagram for obvious reasons, like users are invited to explore and interact, which leads to a deeper understanding and more informed decision making. So techniques we can use to make the most of interactive dashboards. Certain techniques are essential, like filtering, drill downs, link charts, etc. So what is filtering? Users can apply filters to the data, allowing them to isolate specific variables or categories. For example, filtering sales data by region, time period, or product category helps in narrowing down to the relevant data points. Then, drill down. This feature enables users to click on specific data points to dive deeper into more detailed information. It's particularly useful in hierarchical data where users might want to start at a high level and work their way down to the granular details. Now, link charts. Linked or synchronized charts mean that when a user interacts with one visualization, the others automatically adjust. For example, clicking a bar in a bar chart may update the data displayed in a corresponding line chart or map, providing a dynamic, holistic view of the data. So interactive visualizations are not just a trend, that they are quickly becoming an industry standard. As the complexity and volume of data grow, interactive dashboards allow us to analyze data in real time, offering a significant advantage in industries where quick data-driven decisions are crucial. Okay, so now when it comes to visualizing data with a geographical component, um, geospatial visualizations provide a powerful means of mapping and analyzing data. By using geographic information system, which is GIS, we can transform location based data into visual formats that reveal patterns and insights that would otherwise be hidden. Now, geospatial visualizations involve mapping data in relation to its geographical coordinates, allowing us to visualize trends or patterns on maps. Whether it's customer locations, logistical routes, or demographic distribution, mapping provides crucial insights into spatial relationships. Now, GIS, like Geographic Information Systems, which is the short form is GIS. This technology enables us to capture, store, analyze, and present spatial or geographical data. It's the backbone of many mapping visualizations and plays a critical role in analyzing relationships between data points in a geographical context. Now, we can use some tools for that, like Google Maps API, which is widely used tool that provides developers and analysts the ability to integrate mapping capabilities directly into applications. It's ideal for plotting locations, routes, and overlaying real-time data. So developers can directly add the Google Maps API so that we can use those. Then Mapbox. Mapbox is a versatile platform which is used to design custom maps that can integrate with a wide range of datasets. It offers powerful styling options to create unique and interactive geospatial visualizations. Now, lastly, we can use Quantum GIS. QGIS means Quantum GIS, which is an open source GIS platform. This is known for its robust features in analyzing and visualizing geographic data. It's used by professionals in a wide range of industries. It also offers data mapping and spatial analysis capabilities. Now let's explore some of the real world applications where geospatial visualizations are invaluable. Like, businesses and governments often need to analyze demographic data to make informed decisions. Geospatial visualization allow us to overlay population data on maps, revealing trends related to population density, age distribution, or income levels across different regions. So that means we can use it on our demographic sector. Then on logistics sector, for industries involved in logistics and supply chain management, geospatial visualizations are essential. Companies can track the movement of goods, optimize delivery routes, and identify bottlenecks in the supply chain by visualizing data on a map. Well, if you think about Uber Eats or DoorDash, you can see your delivery routes, how long it will take, and where it is right now. Like Uber, when you call a ride, you can see where your Uber driver is. So it is basically like that, and more advanced. We can use as more advanced. On real estate, we can have like geospatial visualization are also key in the real estate sector. So the mapping property values, neighborhood demographics, and accessibility to amenities. Stakeholders can identify prime locations for development or investments. So these are the three areas where we can use this GIS, so which is very important nowadays, and this is an advanced technique of data visualization. Okay, now we will look at 3D visualizations. So as we all know, as data sets grow in complexity, we sometimes need to move beyond 2D visualization and need 3D visualizations, which is highly effective when representing high dimensional data or when understanding spatial relationship in critical. So, well, here when you are working with data sets that have multiple variables or dimensions, using a 3D visualization can help in mapping out relationships between different variables that would be difficult to represent in 2D. For instance, in situations where multiple factors affect an outcome simultaneously, a 3D plot can show how these dimensions interact with each other. For data that involves physical spaces or environments, such as geographical data, architectural models, or molecular structures, 3D visualizations provide a more realistic view. This is especially useful for industries such as urban planning, engineering, or environmental science, where the position and distance between objects are crucial. So 3D visualization is very important for those areas. So tools we can use for that. First, we can use Plotly. There are several tools available for creating 3D visualization, but we'll just go with this. We'll just look these three for now. So a graphing library that enables interactive 3D plots, which is what Plotly is. It's especially useful for data scientists who want to integrate 3D visualization directly into dashboards or reports. Now, next is Three.js. This is a JavaScript library that allows for the creation of 3D graphics in the browser. It's powerful for visualizing complex data on the web. So we have, like, when we have a web application or website, we can use this JavaScript library to have a 3D graphics visualization in the browser. It creates like immersive experience, like interactive 3D models. Then we have Blender, so Blender is basically a versatile open source 3D modeling tool. So while it's primarily used for creating animations and 3D artwork, it can be adapted for complex data visualizations also. So especially in fields like architecture or scientific visualization, we can use Blender. Now, so after all of this, we could have some challenges. We still could have some challenges. While 3D visualizations can be powerful, but we can have some challenges. First of all, if 3D visualization often introduce additional complexity, which may overwhelm the viewer. Like, it can sometimes be difficult for users to interpret depth and spatial relationships accurately, especially when viewing data from a fixed angle. Like, if you see on this picture, it is very, like, it's very good, it's looking good for like developers or any other like scientists or who is doing those research or doing the work. But for the users, it might be overwhelming, because it is basically showing data from a fixed angle. So it could be sometimes very complex for the users to understand. So next is, if there is too much information or overly complex design, which can confuse the viewer rather than providing clarity. So it's important to strike a balance between adding depth to your visualization and ensuring that the insights remain accessible. Okay, so when it comes to visualizing data that evolves over time, time series and motion charts provide a dynamic way to represent changes, trends, and movements. These charts go beyond static representations and introduce animation and interaction to bring the data to life. So, data animation allows us to show how variables change over time. Instead of flipping through static graphs, motion charts can reveal the progression of the data points in real time or simulated time, making it easier to spot trends or significant shifts. So, if we see motion charts, these are particularly useful when working with multiple variables over time. Imagine visualizing GDP growth versus population increases across different countries over several decades. A motion chart can show how both metrics evolve, with each data point moving across the screen to illustrate changes. So, if we look at timelines are essential when you want to track events or progressions over time. They can show the evolution of a project milestones, or historical events in a clear linear fashion. So next is streaming data visualization. So this visualization deals with real-time data that updates continuously. this is ideal for monitoring ongoing processes like stock prices, website traffic, or live sensor data. So where the data is always in flux and insights need to be made in real time. So we can use Google Charts, D3.js, and Plotly. These are the tools we can use, but we can use more tools other than these three. So Google Charts, if you know, a free and powerful tool from Google that allows you to create a variety of charts, including motion charts. And D3.js is a JavaScript library that enables highly customizable, dynamic, and interactive data visualization, including animated time series and motion charts in your website or web application. And Plotly, as we already learn about Plotly, it's known for its ease of use and high quality visual output. You can also make the animated charts here. Now, if we do a case studies, like it could be used in historical data analysis. Well, like historical data such as economic data over several decades can be analyzed using motion charts to reveal long-term trends, cyclical patterns, or sudden shifts in key metrics. And then if we have in predictive modeling, time series data helps to forecast future trends based on historical patterns. So by visualizing how certain variables have changed in the past, businesses and analysts can build models to predict future outcomes. So in many modern data sets, especially those related to social media, customer feedback, or academic research, text-based and relationship-based data are abundant. To extract meaningful insights from this type of data, we turn to advanced techniques like text analysis and network visualization. So text data is unstructured and often requires different approaches compared to numerical data. So using text analysis, we can transform unstructured to text into visual representations that highlight important patterns, topics, or sentiments. So a simple but effective method to visualize the frequency of words in a given text corpus. Words that appear more frequently are shown in larger sizes, helping us quickly identify prominent themes or terms in the data. So word cloud, we can use word clouds for text analysis. Now, topic modeling allows us to extract abstract topics from large bodies of text. It helps categorize the text into different themes based on the frequency and co-occurrence of words. Especially useful for analyzing documents, research paper, or online reviews. Then lastly, sentiment analysis helps determine the sentiment or emotional tone behind text data. For example, sentiment analysis can be applied onto social media posts to gauge public opinion on a certain topic. Now, we can use network graphs as well. First, we can use network graphs represent data as nodes and edges. For instance, in social networks, nodes represents individuals and edges represent friendships or interactions. Network graphs help to reveal the strength and structure of relationship in a complex web of connection. So visualizing relationship and connection makes it easier to understand. So we can use tools like Gephi or Cytoscape. So like a popular open source platform for visualizing large scale networks. Gephi is known for its speed and ability to handle massive datasets. Also, on the other hand, Cytoscape is widely used for visualizing molecular interaction networks and biological pathways. So, as I said, we can use those techniques for social network analysis and text-based insights in customer feedback. Creating and effective data visualization is as much about following good design principles as it is about correctly interpreting and presenting data. To ensure your visualization deliver insights clearly and avoid confusion, adhering to best practices is essential. So first, we should have clarity. You have to ensure that your visualizations are easy to understand at a glance. The audience should not struggle to read your or decipher what you are trying to communicate. Then it should be simple. So a good rule of thumb is like if a visual element doesn't add value or convey insights, it should be removed. Too many design elements can distract from the main message, you know. So next is consistency. You can have consistency in colors, fonts, chart styles, and scales, which can make the visualization more professional and easier to follow. Now you can avoid some common pitfalls. One of the most common mistakes is trying to pack too much information into a single chart or dashboard. So you can avoid these. This can overwhelm the viewer, you know. And then be cautious of visual choices that may unintentionally mislead to the audience. For instance, using inconsistent scales or truncating axes can distort the masses, which can lead to incorrect conclusion. Now, so effective data visualization go beyond just presenting data. They must communicate the insights effectively. To do this, it's important to tailor your visualization to your audience. So, for example, high-level executives may prefer simple summary visuals that communicate key trends, whereas the data analysis may appreciate more complex, detailed charts that allow for deep exploration. Understanding your audience needs and expectations ensures that your visualizations are impactful and informative. So now, these are the popular tools: W, Power BI, D3.js, R, Python. These are the popular tools and technologies you can use, and you can also have custom visualizations like building from scratch using JavaScript libraries like D3.js. That's totally up to you and depends on the data type you have. Now you will go through these case studies I have in detail. So you will go through the case studies and you will let me know on the discussion on module that if you understand the case study and the lesson you learn. And these are the future of data visualization, like emerging trends. So as we already know, AR and VR, that means augmented reality and virtual reality in visualization, are the future. And AI driven visualization means using artificial intelligence is our future. So these two are the emerging trends we will have in our future for sure. So like automating and enhancing visual processes, that could be the role of AI. Like before you have to do some sort of visualization by yourself or doing any software, but then the AI can do those works automatically. So these are our future, and that's the end of our lecture. And you let me know if you have any question or concern, and you can always email me and have a one-to-one session, or you can uh, just pin out a question, or you can post a question on our discussion forum. We have a discussion forum every week, so please let me know if you have any question. So thank you.